Adsorption isotherms. These are the curves which are actually plotted between the amount of the gas adsorbed by the adsorbent with respect to the variation in the pressure. Now, during this study, the temperature is kept constant, and that is why the graphs plotted are called adsorption isotherms, because temperature remains the same. The most important adsorption isotherm we study is called Freundlich adsorption isotherm. It was studied by Freundlich, who studied the variation of the amount of the gas adsorbed by the adsorbent along with the pressure. When the pressure is changed, how much is the gas adsorbed? And for this, the temperature was kept constant, and that is therefore the study of the graphs are called Freundlich adsorption isotherms. Now, the graph plotted by Freundlich were like this. He plotted x by m with pressure, and the graphs were coming out to be like this. These graphs can be divided into three major regions. If O is the origin, this is the A we have, this is the B we have, and suppose this is going like this, that end is C. What we find is, but before moving into the details how this varies, let me explain it to you. X is the amount of gas adsorbed on m amount of adsorbent. Therefore, x by m tells us the extent of adsorption, to how much extent the adsorption has taken place. Now, when this extent is plotted with pressure at constant temperature, the graphs obtained are called, particularly in this study, are called Freundlich adsorption isotherm. Now, as I told you, this graph can be divided into three major areas or into three major parts. Now, the three major parts of this graphs are OA, AB and BC. Now, during OA, when pressure is low, what we find is this extent of adsorption is directly proportional to the pressure, or we can write P to the power 1, because it is almost as a straight line which is passing through origin. So, during this time, this is directly proportional to P to the power 1. Now, also during BC, what we find is when pressure is very high, the extent of adsorption is almost becoming independent of pressure. It is almost becoming parallel to x-axis, which shows saturation has been achieved, which shows that now it is independent of pressure. But the most important situation is during moderate pressure, is during the AB stage. Now, during AB stage, what we find is, now during AB, when pressure is moderate, it's not very high, it's not very low, the extent of adsorption is proportional to P to the power 1 by n. You need to understand here, during this phase, the extent of adsorption is directly proportional to the pressure to the power 1. During this phase, it is independent of pressure. So that means during this phase, the power of the power to the pressure is between 1 and 0. So it is 1 by n. So it's any positive integer, where n is any positive integer. So what we find is this is during the moderate pressure, where we normally do our studies. Now this proportionality is opened by a constant called K, and it becomes P to the power 1 by N, where this K is called Freundlich's adsorption constant. So this is the major equation we have from the Freundlich adsorption isotherm. Now this is our major Freundlich adsorption isotherm equation is, which shows how the extent of adsorption or the amount of the gas adsorbed by the adsorbent varies with the pressure at constant temperature. Now what we can do is we can plot in order to verify this equation, x by m equal to kp to the power 1 by n, take log of both sides. What we get is log x by m equal to log k plus 1 by n log p. So this is how the same equation can be written out in terms of log. Now you compare this equation with y equals to mx plus c in order to check its validity. Now if we want to check this, we will be plotting along y-axis the log x by m, the extent of adsorption. Your x is your log p. It will, since this is positive, it will be a straight line. Intersection will be at log k, and remember the slope will be equal to 1 by n. So this is how, and if we get a straight line, this equation is valid, and it is observed that the Freundlich adsorption isotherm is very much valid, in which and the equation is very much valid, which shows how the extent of the adsorption varies with the pressure at constant temperature.